Okay, so going back, and hopefully it sounds like the audio is better now. Coming back from break, we're looking at a problem where we were trying to build this bridge, or not a bridge, we couldn't build a bridge. And so they had to go around a bay. And so we're trying to find the distance of highway that needed to go around this bay. Okay, sorry. Sometimes when the other people's mics are on, it causes feedback. So we got this picture. We're given this information. We're trying to find this distance of highway that's needed. And that's all the information that we were given and to go by. So looking at this, and we need to use some right triangle information. So we have a right triangle here. So that's nice. We know what this angle is in here. And so we could figure out what this angle of our triangle is in here, because we know that this whole angle altogether would be 180 degrees for a straight line. So I'm going to look at 180 degrees minus the 130, and that's going to give me 50 degrees. So I have 50 degrees, and I know that this is 1 mile. And so basically from this angle, I have an opposite, and we want to know the hypotenuse. And so I don't know what we want to call this. Maybe we can call this C. And so for this stretch of C, we're going to use, well, opposite and hypotenuse is sine. So we have sine of 50 degrees is opposite of that, which is 1, all over the hypotenuse, which is C. So we can get C by itself by multiplying first both sides by C. So we would have C times sine of 50 degrees is equal to 1. So now we want to divide both sides by sine of 50 degrees to get that length. So C has a length of 1 over sine of 50 degrees. Okay, so we figured out what this piece of our highway is. So we can also make another right triangle. We're doing this. Let's see, I'm just trying to think. So I know we can figure out what this angle is right in here. Again, same kind of idea as the other side. I know that this is 140 degrees. So a whole line, an angle for a line is 180 degrees. And so this right here would have to be 40 degrees. And so now I'm assuming, and I'm not sure if I should be assuming this, that this right here is a horizontal line. Well, I'm just going to assume. And if I assume that, that means that this right here is 1. Okay, so if that's 1, again, I'm going to use, I have an angle here, opposite, and I want hypotenuse. So maybe we can call this side over here D, like D. And so D, so sine of, what am I at, 40 degrees is going to be opposite, which is 1, all over the hypotenuse, which in this case we call D. So we want to get D by itself. And so again, multiply both sides of our equation by D. You can get D times sine of 40 degrees is equal to 1. Divide both sides by sine of 40, we get D is equal to 1 divided by sine of 40. So I need one more piece of the puzzle. I need to figure out what this distance is in here for our highway. And so I know that this whole distance in here is given to me to be 3. So I need to figure out what this piece in here is. Maybe call it X. So I know also that we have a right triangle. I could be able to figure out what these sides are by either using trigonometry or by using Pythagorean theorem, because technically we have now 2 lengths of our side. So this is where poke around at the beginning. But maybe we need to do that. So I need to label a couple more sides. And so maybe let's go back to this triangle that we first worked with. You know that this right here was 1. We're trying to figure out what this length is in here. Let's call it A. And we just found what this length was in here. This was the sine 1 over sine of 50. So by Pythagorean theorem, my 1 squared plus a squared is equal to this 1 over sine of 50 squared. Or I can say that a squared is equal to the hypotenuse 1 over sine of 50. That quantity squared minus 1 squared. Talking about distance, so it would be the square root, and I'm not going to look at the negative. 1 over sine of 50 degrees. 1 squared is 1, minus 1 underneath the radical. Okay, so this is the length of A. And now if I find the length of this piece over in here of our triangle, that base of the triangle. So I'm trying to figure out what this is. So let's just rewrite our triangle. We thought this was 1. And we just found that this was D, which is 1 over sine of 40 degrees. Maybe we can call, we don't have B in here, let's call this B. So by Pythagorean theorem, we know that B squared is equal to the hypotenuse squared, so 1 over sine of 40 squared. Minus the other side squared, 1 squared. Take the square root of both sides. So I have 1 minus sine of 40 squared, quantity squared, minus 1. So basically my side x, that length I need to figure out, well, I know this whole length in here is 3. So x is equal to the whole length of 3 minus a minus b. 4, x is equal to 3 minus a, which we saw was the square root of 1 over, oops, this piece has to be squared, 1 over sine of 50 quantity squared minus 1, and then minus this radical of 1 over sine of 40 quantity squared for that fraction minus 1. Okay, so I think we're pretty much almost done. So the highway distance around the bay is our distance of I'm going to call it capital D, rad little d over there, capital D, which is equal to the length of C, side C, plus our length of X, plus our length of, call it D. So we have C Yeah, I thought I could do it and save some time. I can't. So I have distance is 1 over sine of 50 degrees plus x, which was that whole 3 minus the square root of that whole bit. And then plus b, d. And that is going to be in terms of miles. So if I start approximating now, if I approximated this side C, that side C, 1 over sine of 50, that was 1.31. If I was looking at side X, hold on, it's going to take me a moment. Gotta be careful with parentheses again. So under the square root, I'm gonna have a parentheses for everything underneath the radical. Then I'm gonna have another parentheses just for the 1 divided by sine of 50 degrees. Close my angle, close my fraction. I have to square that. Then I have to minus 1, and then I have to close my other parentheses for the whole underneath the radical. And so if I do that, and I'm just going to do this a little bit in pieces here. So this piece right here is 3 minus, this is 0.84. If I had a different calculator on me, I wouldn't do it in pieces. And then I have to do the same thing with a radical minus, and I'm going to change that to a 40 degrees instead of a 50 degrees, but it's almost identical. And so if I do that, that is approximately 1.19. So if I took 3 minus 0.084 minus 1.19, just to get my value of x, so something wrong. So 3 minus minus 1.19. That gives me, that distance of x was approximately 0.97. And then 1 divided by sine of 40, that gives us approximately 1.56. So adding all three of those lengths, we get that 3.84. So I noticed, looking at the answer in the book, they have 3.83. And so that could have been because I rounded somewhere in there. If for some reason you're off by that little of an amount, then text me, not text me, email me when you're done with that assignment. Just say, can you go back to number, section 7.3, number 25. I was off by 100th and got marked wrong. And I can go back in and give you credit. I can't go back into a homework assignment and give you credit for a problem until after you turn it in, or I believe you're not able to get back in and change anything on the assignment once I've changed your grade. So that is the application. So a little bit of challenging, kind of having to work through certain things, but hopefully with me kind of thinking and thinking through this kind of helps you how the process of going through these problems. So I'm going to change the page and we're going to jump into starting to graph these trig functions. So we're going now into 7.6. Graphing, we're just going to graph sine and cosine. Okay, so we're going to graph sine and sine functions in the form of y equals some coefficient times cosine b of x, and y equals a times sine of b of x. So let's kind of go back to the unit circle. Okay, kind of let's put this together while we're doing this. And so we're going to let x represent not like x is any real number, because we're going to be graphing this. But let's talk about cosine. So notice that cosine at 0 is 1. Okay. So let's go on here. So when x is 0, we have 1. We know that here, when x reaches pi halves, so cosine of pi halves, notice that we have a value of 0. When we go to pi, our value for cosine of pi is -1. A point here. When we get to 3 pi halves, cosine of 3 pi halves is 0. And then 2 pi, cosine of 2 pi gets us back up to 1. We talked about this being periodic, so it's going to start repeating itself every 2 pi. And so I'm going to get this wave. Think about it on the other side. If I went negative pi halves, so that was the clockwise direction, I'm putting x cosine of negative pi halves is 0. Negative pi, I keep dropping.
¿No?
No andaba ya, ¿no? Fíjate, se los mochó todo porque se hicieron grandes y ya no andaban, mira. No sé qué les pasó. O sea, que venimos, que nos ven estudios de camping y ahora venimos y desechamos.
Okay, so notice that we have some important points in here. And if we can do this with any of our trig functions, it's going to make our life really, really easy to graph. So this is right here is the graph of y equals this cosine. So we can kind of get that general idea of what the graph would look like of sine. By looking at the unit circle again, one way to think of it. And so remember, a unit circle, sine is the y value of your point. And so at 0 degrees, or at 0 radians, our y value of that point is 0. And so our y equals sine of x, that graph has a point at the origin, 0, 0. When we get up to pi halves, sine of pi halves, though, is 1. So pi halves. Going to pi, our y value at pi, the negative x-axis, is 0. At 3 pi halves, our y value goes down to -1. And at 2 pi, sine is 0. Here is a sketch of one period of the graph of y equals sine of x.
Professor,
Yes.
how are you knowing like what points to plot?
I am starting and I'm knowing that I always want to kind of get the main points. And so my main points are basically, if I think of it around my unit circle, are the values where it's going to hit either the max, the min, or where it's going to cross the x-axis. So basically, I am just going through And remember, if it's on the unit circle, our point xy on the unit circle is actually thought of as, you can think of this as cosine of theta, sine of theta, if we're on the unit circle.
Thank you.
And so I'm using that to get those values to plot it on the xy axis. Okay, so we kind of talked about yesterday that the range for our cosine and our sine function, notice, are between -1 and 1. We can plug any value in for a real number for our angle, and we would get back some value. And so our domain is all real numbers. Our range then is between -1 less than or equal to our trig function. Cosine of theta is less than or equal to 1, or -1 is less than or equal to sine theta. We said our period in this case was 2 pi. So that period can be affected by, if we multiply, we call the argument x in this case. If we take sine of that argument is not just 1 times x. And we'll talk about that in a second. And then we have the amplitude. This is equal to, and we'll talk about this again in a second, the absolute value of A, where A is equal to the number in front of y equals sine x, or so notice here, our number right in front of here, this is our A value. So A is 1. This number in front of cosine x, this is our A value, the coefficient we're multiplying by the trig function. So that's 1. And so our amplitude for both of these functions is 1. We're going to start getting into shifting later. Think of this right now. I kind of think of this x-axis as my midway line. It's the halfway point between my maximum and my minimum value for my y values. Another way, if we start shifting things, we can find this is amplitude is equal to the max minus the min all over 2. Max and min always relate to the y value of the point. Well, of the max or min point. So notice that our maximum value in each one of these cases, we reached 1. And our minimum value in each one of these cases, -1. And so if I look at my amplitude, which normally we call A, this is equal to the max, which is 1, minus the min, which is -1, all over 2. So that's 1 plus 1 over 2, which is 2 over 2, which is 1. Which I had told you before, which is the coefficient, absolute value of that coefficient in front. Okay, so let's say we wanted to graph something. Actually, one other thing before we do that. Notice that the graphs of sine and cosine are almost identical. So basically, if I took one of those graphs and I shifted it pi half units over, just one of them, it would actually lie on the other graph. So if I took cosine of x and I shifted that all over pi halves, then my maximum value that was at 0, 1 is now becoming the same maximum value for sine that function. And these are called, and because of that, these are called sinusoidal, and I don't know if I'm pronouncing the right curves. Writing it right. Sinusoidal functions. So sinusoidal.
Hold on, what is that? Is it sinus? Is that an I? That little letter?
Yeah. So I don't even know if I'm pronouncing it correctly. Sinusoidal curves. Basically, sine of x could be written as cosine of x minus pi halves. Basically, sometimes you're given information on a problem, and basically depending, it could be either a sine or a cosine curve. So you're going to have two separate different equations depending on what you chose to use, cosine or sine. I don't know why it's going to do that. So we're going to use shifting to help us graph this. So let's say you wanted to graph y equals -2 sine of x. Basically, that -2 in front of this sine x just stretches the graph. Of sine of x, and we flex it off the, think of it, if you're changing, you're multiplying this by a negative sign, you're changing your y value, so it's a flexion across the x-axis. So if I go back up to my sine curve over here, multiplying this by -2, this first point, 0, 0, my y value by -2 doesn't do anything to that point. It stays here at 0, 0. When I get to pi halves, if I multiply my y value by -2, it's now not going to be at 1. Instead, it's going to be at -2. And then if I'm at pi, well, sine of -2 times sine of pi, well, sine of pi is 0 times -2. That -2 number in front doesn't change anything. And then when I'm multiplying my y value at 3 pi halves by -2, it's now up here at +2. 2 pi 0. More of a curvature. Kind of idea. So knowing the general shape of the original, we can use transformations are really helpful in order to graph it. So just want a couple things to remember. So negative in front of your trigonometric function, that's a reflection. It's going to just change your y values.
Do you mind going up to the graph again so I can copy it?
X.
That value in front of your trigonometric function for sine and cosine actually is going to tell you the max and the min. So I know my A value, my amplitude, A is equal to -2. My amplitude is equal to the absolute value of that. Okay, so number in front of the angle that you're plugging in, or the trigonometric function you're taking that number of. So let's say we have y of cosine 2 times. This cosine of theta a period between, we could have one period for cosine of theta, same thing with sine, between 0, theta, and 2 pi. So basically, how we can figure out the start and the end point of our new period is we can rewrite this argument, this is called the argument, and see how much in between what the pi or the period normally is. So 0 is less than or equal to 2x, which is less than or equal to 2 pi. So get x by itself. We can divide every side by 2. We get 0 is less than x is less or less than or equal to x is less than or equal to pi. So this is our new period.
Professor, I had a question.
Yeah,
Why did you divide by 2?
I'm trying to get x by itself to see what my new period of my function is. So if this was just 1 times x, my period is going to be between 0 and 2 pi. But this coefficient in front of the x here is going to affect that length of the period. So it's either going to make it so it takes longer to make a way around to start over, or it's going to make it so it goes faster.
Okay.
In this case, it's making it go faster. So my length of the period is just pi. Whoops. So the main thing on here, if we have a start point at 0, and I have an n value of 1 cycle of my period at pi. What's really kind of neat, if you can figure out what the start point is of a period, the end point of a period, we can find really important points. Our quarter value, our halfway mark, and our 3/4 value of that period. And that's either going to tell us where our max, our min is, or where it's crossing the x or y axis, depending on which trig function we're using. And so if you know the start and the end, halfway between 0 and pi, we'll add the two numbers together and divide by 2. So halfway between 0 and pi is pi half. If I wanted to find the halfway distance between 0 and pi half, I would have to sum the two together and divide by 2. Sometimes it's actually easier to think of it as multiply by a half. So this distance between 0 and pi halves, halfway distance, is pi 4. If I want to find the halfway between I want to figure out what my 3/4 value is, that's a halfway mark between pi halves and pi. So to get that number, I can take 1/2 pi halves plus pi. I'm going to write pi as 2 pi over 2, just the common denominator. This is 1/2 times 3 pi halves, which is 3 pi fourths. So let's just graph it real quick, or let's put those important points on the graph. Okay, start at 0. That's an important point. We have a pi force. It doesn't matter how we make it. We just know these are equal distance. A pi halves. We have a 3 pi force. We have a pi. I know my whole period of cosine is going to fall in there. My coefficient in front of cosine is 1. I know that cosine of 2 times 0 is cosine of 0, which is 1. So my maximum value is 1. I haven't shifted anything from the original. But now when I get to pi fourths, everything just kind of cancels. Okay, sorry about that. I didn't even push the off button, but my computer turned off. Or screen went black. So hopefully you're still there. Are you guys still there? Okay, it's almost over. It's almost over, I swear. Okay. So pi fourths, we're going to come back down and hit at 0. Pi halves is the minimum value. So I'm going to hit down here at -1. We're going to hit back up the x-axis and back up here. So it's always going to be kind of the same general shape. It's just that the period is moving a lot faster. It's every pi now because of that number in front of the x when we're taking the trigonometric function of that angle or number. Okay, so we'll definitely do more examples and I'll go through more of the process again. But knowing or remembering transformations of graphs is a little bit helpful in doing these. And I'm hoping I get to that in college algebra today. Okay, so